this. What happened, guys? This is sad. Fair. Yeah. Write this question. Let me know if you're done. Let me know if you're done. Okay. Write this down. I hope all of you understood this question and you can do it, right? You just have to tell me which of the following will have a higher pH value. You don't have to calculate the pH values. I hope you can just look and tell. Yes, Hishma, Matthew, Samira, tell me, guys, for the first question, which will have higher pH, 1 molar NaOH or 0.01 molar NaOH?
Zero 0.1.
Yeah, okay, fine. So the 0.1 will have, in this case, 0.1 molar will have higher pH value than 0.01 molar of NaOH. What about in the second case, which will have higher pH?
0.1.
हाँ देखिए यही 0.1 is more acidic or 0.01 is more acidic? Tell me, Samaira.
0.01.
हाँ, tell me,
Yeah,
Samaira.
yeah. 0.0.
हाँ, ये क्वाड्रेटिक इक्वेशन बना के ये सब चीज में आप लोग मत ये कीजिए प्लीज, है ना? डोंट डू सिली मिस्टेक्स हियर. नाउ यू टेल मी हियर, थर्ड केस which will have higher pH.
0.1.
अरे दोनों 0.1 है, NaOH या HCl?
HCl.
पानी पी लीजिए.
Okay, yes, I got NaOH. Okay.
Acid has lower value of pH. Okay, it's quite counterintuitive. I also had problem when I was in 11th, not in 11th class, but in I think when was this pH introduced? 9th, 10th class, na? 9th class or 10th class?
10.
10th. आप लोगों को पता है, आप लोगों ने तो एग्जाम भी नहीं दिया 10th का, ऐसे ही पहुंच गए 11th में. Okay, what about the fourth one, which will have higher pH?
CH3COH.
Yeah, okay. I hope all of you understand, because this is a weak acid, right? Then that means it will
HCl is a
liberate
strong
less
acid.
number. Yeah, so HCl will be contributing the complete 0.1 more of H plus ions, and CH3COH will be only contributing a fraction of H plus ions. Okay, a fraction of, so 0.1 molar of CH3COOH. What about this fourth one? Sorry, fifth one.
NaCl.
What about correct. Now here we will have 0.01 molar of NaCl, because NaCl will have approximately 7, no? Around 7. Okay, so write this down. Let me know if you are done.
Done, sir.
Okay, good. Write another question. Calculate the pH of 1 into 10 to the power minus 8 molar of 1 into 10 to the power minus 8 molar HCl solution. Chaliye, solve this and let me know if you are done. Okay, chat. Wow, wow, Sara, wow. ऐसी I live for these moments. I live for these moments. Sara, can you please turn the mic on? Sara, can you please turn the mic on?
Yes, sir.
Okay, so you said pH is equal to how much?
8.
8. Okay, that means when I am adding an acid, the solution is becoming basic.
Sorry.
So no, this was obvious. Don't worry. Okay, I hope everyone will be somewhere around this answer only. है ना? So listen, when we talk about strong acid or strong base, and we say now that the concentration of the strong acid, it is going to be the concentration for H plus ion, and the concentration of the base, a strong base, will be equal to the concentration of OH negative. We say only this, see, because if I look at, so in our solution here, there are two things. Now there is H2O also, and there is HCl also, right? Now both of these are giving H plus ions, right? If I add HCl also, now technically speaking, in all of the cases now we should be adding the concentration of H plus ion that I am getting from the concentration of H plus ion that I am getting from the H2O plus the concentration of H plus ion to get the answer. Okay, but the concentration of H2O is so small. And what is the concentration of the concentration of H plus that I am getting from water? And this is the concentration of H plus that I am getting from water. This is so small, that is 10 to the power minus 7, that we don't consider it when we have a strong acid and a concentrated strong acid. But when we have a very diluted strong acid, then we can see that, okay, fine. That means this concentration is 10 to the power minus 7, and the concentration that I'm getting from H plus is 10 to the power minus 8. Sorry, yes or no? Tell me. The concentration of H plus that I'm getting from H2O is 10 to the minus 7, and the concentration of H plus that I'm getting is 10 to the power minus 8.
Yes.
Yes or no, guys?
Yeah.
Now these are comparable. Now these are comparable, and hence we will have to add it. Okay, so let me just write here. The concentration of H plus, it is 10 to the power minus 7, and the concentration of H plus from HCl, it is equal to 10 to the power minus 8, because this will be equal to the concentration of HCl only, because all of the moles of HCl is getting dissociated. Now you just have to add it. Yes or no? 10 to the power, so how will you do this? 10 to the power minus 7 is from H plus 10 to the power minus 8. So let me give you some time and let us see who can add this. I'll be happy if you can add this. So the total concentration of H plus will be equal to the concentration of H plus from H2O plus the concentration of H plus from HCl. This will be equal to 10 to the power minus 7 plus 10 to the power minus 8. Oh, guys, no one is able to solve this. See, 10 to the power minus 7 plus, you can write
1.1 into 10 raised to minus 7.
Yeah, correct. 1.1 into 10 was minus 7. So okay, let me show you guys. So 10 to the power minus 7, okay, plus 10 to the power minus 8. So how can I write 10 to the power minus 8? I can write 10 to the power minus 8 as 0.1 into 10 to the power minus 7. Okay. And then we can take common 10 to the power minus 7. And from 10 to the power minus 7, you'll have 1 plus 0.1 into 10 to the power minus 7. Correct? And this will be equal to 1.1 into 10 to the power minus 7. Got it? All of you, yes or no?
Yes,
Tell me.
Yes, sir.
Okay. No. Listen. No. The story is not complete here. So till now, what we have seen, so you all know, right? If I will add the HCl into water, then this reaction of the water reaction, it is going to go backwards, right? It is going to go backwards. Now, let me show you what has happened to the H plus ion. Okay, let me show you what has happened to the H plus ion. So you had H plus ions, fine. Now this H plus ion was initially 10 to the power minus 7. Okay, now 1.1 into 10 to the power minus 7. And now at equilibrium, now after the change, we have got 1.1 into 10 to the power minus 7. The OH negative ion was 10 to the power minus 7. It is still 10 to the power minus 7. Yes or no? Tell me.
Yes, sir.
Yeah. Now you can see that if I multiply these two things, now 10 to 1.1 into 10 to the power minus 7 and 10 to the power minus 7, this will be equal to 1.1 into 10 to the power minus 14. This is the Q. And we know the K should be equal to 10 to the power minus 14. That means some of this OH negative and H plus ion, they will be, what will happen to them? They will react with each other and they will form H2O. Because when we add acid, what happens? The concentration of H plus increases and the ionization of water reaction, it will go backwards a bit. Okay, it will go backwards a bit. So what is going to happen in this case is, what is going to happen? You will remove some from here and you will remove some from here, okay, to make K that is equal to 10 to the power minus 14, 10 to the power minus 14. Now, a simple thing is that you can see the whatever the change was here, now the change was of 0.1. Okay, the change was of 0.1. Then what will happen? Half of this will be getting reacted. Half of 0.1 will be how much? 0.05 into 10 to the power minus 7 of H plus will be getting reacted with 0.05 molar concentration of OH negative. Okay, because what is happening? H plus is combining with OH negative to form H2O. Because the concentration of H plus has increased, so the system will move towards backward reaction. And the increase was here of 0.1 into 10 to the power minus 7. Then half of H plus and half of OH negative will react. And let me give you the answer. This will be 1.1 minus 0.05. 10 to the power minus 7 is common in both of them. And here you will get 1 minus 0.05 into 10 to the power minus 7, right? So what will be this equal to? The concentration of H plus will be equal to 1.05 into 10 to the power minus 7. And this will be equal to how much? 9.95, no? Or 9.5. 0.95 into 10 to the power minus 7. Yes? Tell me, guys. Yeah, okay, fine. Now this is the concentration of H plus, 1.05 into 10 to the power minus 7. 10 to the power minus 7. So whatever we did here now, that you please always do like this, so you will not have to calculate the quadratic equation. So you just start from the H plus and see whatever the changes, and half of this will be getting reacted. Okay, half of this will be getting reacted, and it will be forming H2O, and it will be forming H2O. So you have the concentration of H plus ions is equal to 1.05 into 10 to the power minus 7. Now you have to calculate the pH. What is pH? Minus log of 1.05 into 10 to the power minus 7. I hope you all know now. Minus log of, you can write this as 105 into 10 to the power minus 9. Then this will be equal to minus log of 105 plus log of 10 to the power minus 9. Okay, So calculate this. Let me know if you're done. Give me the answer. Sarah, 6.3. I think it will be a bit higher. Not 6.3, I guess. Let us see. Really. Seven. So 7 into 15, that means 7 into 5 into 3 minus 9. Then we have a minus sign here. This will be equal to minus log of 7 plus log of 5 plus log of 3 minus 9. Log of 7 is 0.84 plus 0.7 plus 0.48 minus 9. Calculate this, tell me. You got similar kind of simplifications? Yes or no? Sarah?
Sir, I took the LCM wrong.
Okay, you got the LCM wrong. Yeah, calculate this.
Sir, I'm getting 6.98 only.
Who is getting 6.98?
Sami.
That's a 6%.
That is fine ना 6.9 तो हम कहाँ बोल रहे 6.98 गलत है 6.98 is fine, correct. Sarah actually said 6.3. That is why I said it will be a bit higher, है ना? So this is the pH. Okay, this is the pH. Okay, done.
Yes, sir.
Okay. So now write relationship between pH and POH. है ना? pH means minus log of H plus ions and POH means minus log of OH negative ions, right? OH negative ions. So for this, we know the concept. That means we are just trying to derive a relationship between the concentration of H plus and concentration of OH negative. And please remember that there is a relationship, that is the concentration of H plus into the concentration of OH negative. It is going to be equal to 10 to the power minus 14, right? This is always true. Now I can take log on both sides. So I will write log of H plus into OH negative. It is going to be equal to 10 log of 10 to the power minus 14. And then I can write log of H plus plus log of OH negative is equal to minus 14. Yes or no? Because this minus 14 will come down. We'll get minus 14. Then I will multiply by minus 1, like in the complete equation, and we will get minus log of H plus minus, rather can I say plus minus log of OH negative. This will be equal to 14, right? Because minus minus will be 14. So minus log of H positive, this is equal to pH. Minus log of OH negative, it is equal to OH, POH, and this will be equal to 14. Okay, so just write this down. Let me know if you're done.
The answer.
Done, all of you?
No, it's
Okay. Acha, Sara and okay, Sara and Zainab, do you have any doubts? Did you do any questions from the assignment, Sara? From the
Yes, sir.
NCERT? You have doubt?
Yes, sir. One second.
हाँ बताइए बताइए. There is only one major chapter left, hydrocarbons. That is going to be fine because we have already done organic chemistry, है ना? So we are starting hydrocarbons, and whenever this equilibrium will be completed, because I want to take all the dots and everything. This is a huge chapter, and you will be getting many questions from equilibrium. Okay, that is why 7.44. Okay, wait a second. Okay, so I hope you calculated till what is the concentration of phenolate ion in 0.05 molar solution of POH, right, Sarah? I think you have doubt in the next question. That what will be the degree of ionization if the solution is also 0.1 molar in sodium phenolate. Yes, Sarah, did you not get anything?
Well, actually, I was confused.
No, actually this question and the next question also, it has kind of two parts, you can say. It has two parts. So one part we have discussed that part, and the other part we will be discussing it today. Okay, so see this question. The ionization constant of phenol is 1 into 10 to the power minus 10. What is the concentration of phenolate ion? What is the concentration of phenolate ion in 0.5 molar solution of phenol? So this is one question. Okay, now let us deal with this question. And this part of the question, see in this question what they are saying, what will be its degree of ionization if the solution is also 0.1 molar in sodium phenolate. So we are adding two things. They are saying that we are adding also phenol. We are also adding something other which is known as sodium phenolate, which has a structure that means there is a benzene ring and O negative and Na positive. So they are adding this salt and there is this phenol. Okay, so we have not discussed what will happen if I add two different things in one solution. Okay, so I think till here I can help you, but you need to answer me a few things. So the ionization constant of phenol. So that means they have given what? Ka? Yes or no?
Yes.
10 to the power minus 10. Correct? because phenol will dissociate how? You must know how the phenol dissociates. Acha. Okay, fine. I understand. So you have a doubt. This you can say that it can dissociate in two ways, right? Are you confused in that? Tell me.
Yes.
OH negative. Or will it dissociate like this? Is this your question? Hmm? How will it dissociate, A or B?
Yes, sir.
Okay, fine. So see, this benzene and phenol, now, I hope you know that this is not the complete structure, right? The complete structure is the original structure is the resonance hybrid structure where we have a partial double bond here and there is a partial double bond everywhere else. Yes or no? Tell me.
Yes, sir.
Okay. Now, so there is only one bond in OH, and if I want to break the CO bond, right? This is the CO bond, and then we have the OH bond. So if I break this OH bond is broken, then I will get this B answer. And if I break this carbon oxygen bond, then I will get the A products. Yes or no? Itna aa raha hai aapko, Sara?
Yes.
Now you tell me, what do you think? A single bond will have more strength, or if we have two bonds, one bond will be stronger, or two bonds will be stronger, or like 1.5 bond will be stronger? Which will be stronger? What do you think? 1.5 bond will be stronger, right? So A is stronger. That means what will happen? The OH bond will break, and we are going to get these products. Fine.
Yes.
Okay, fine. Now this question would have been a bit easier if they said that the Ka of phenol is this much, and because they said ionization constant in both of these reactions, you can say that they are ionization. So OH, they will always dissociate. It will always dissociate into H plus, and this is the phenolate ion. From phenol, we will get the phenolate ion. This is the phenolate ion. This is a proton. This is the proton. Okay. So they have given you Ka, and what do you think? Ka is 10 to the power minus 10. So this is a weak acid or strong acid?
Strong.
Yes. Okay. How do you say strong or weak?
On the pH. Depending on the pH.
pH to nahi diya na. Where is the pH? By looking at Ka, how do you say which is strong and which is weak? Tell me. बताइए. अच्छा.
If pH is high, pH will be high.
Okay, fine. So start with acid now. Start with acid. So tell me, a strong acid, then how will you see? In the most basic terms, what will you say? A strong acid which has higher concentration of H plus ions. Yes or no?
Yes.
Okay. That means if I will have a strong acid, then we will have more of products than of reactants. Yes or no?
Yes.
Okay. So we will be having more of product than. Now look at this particular. You look at this Ka value. If you look at this Ka value, is 10 to the power minus 10. And we have learned about extent of reaction. Yes or no? In chemical equilibrium. Extent of reaction, and we divided into three parts. You remember that? If the K is greater than 10 to the power 3, or it is less than 10 to the power minus 3. You remember this, Sarah?
Yes.
Haan, hai na? So if K was less than 10 to the power minus 3, then where was the reaction? It was more towards reactant side or product side. Can you flip some pages and tell me? Extent of reaction. It will be second lesson or second lecture or something, I guess. Second or third lecture. Not on first lecture for sure. I think it is in the second lecture. Yes, tell me.
It will go to the product.
What did you say? It will be towards
-3 or +3.
what are you saying? I could not hear. Can you keep the mic on, please?
-3 or for +3.
क्या -3 और +3? अरे ये सिचुएशन
10
बताइए
to
ना
the
हमको।
power -3.
अरे what is our situation? Tell me. We have k na, so k is less than 10 to the power -3 or more than 10 to the power -3. You tell me which is the situation here. What is the situation for us right now? What is the k?
10 to the power -10.
10 to the power -10. So now you tell me na, it is greater than 10 to the power -3 or less than 10 to the power -3. What is the case? Less than minus. Okay. So this is the k is less than 10 to the power -3. Okay. So now you tell me reactant side, product side. बताइए.
Reactant.
Okay, fine. Reactant side, है ना? Now see, you can also answer this in this way. You have, this is PHO negative. Constant K will be the product into concentration of H plus. Right? Divided by the concentration of PHOH, phenol. Yes or no? Tell me. You know this now? बताइए.
Yes.
So this will be equal to 10 to the power -10 upon, I can write 1. Yes or no? बताइए. Can I write it like this? अरे जल्दी बोलिए.
Why 1?
एक तो बेसिक मैथ भूल जाते हैं. इतना लिख सकते हैं हम. ये दिया हुआ है ना. We can
Yes,
write this
sir.
much. है ना? So can I not just write this as 10 to the power -10 divided by 1?
Yeah.
अगर हम 2 लिखे चाहे 2 by 1 लिखे, कोई फर्क नहीं पड़ता है.
Yeah.
Oh my god. Oh my god. Oh my god. Oh my god. Okay, fine. अब तो हम तो लाइक कुछ और ही करने वाले थे, लेकिन हमको डर लग रहा है अब करने में. देखिए, कैन आई राइट दिस एज 1/10 to the power 10? सारा?
Yes, sir.
अब बताइए. Now you see what I am writing. PHO negative into the concentration of H plus divided by PHOH. It is equal to 1/10 to the power 10. Now you tell me, it is a strong acid or by this information, है ना? By this equation that was already given to me. Now you tell me, it is a strong acid or weak acid? Can you see the relative? Can you see the relative concentration of the acid, undissociated acid, and the H plus? नहीं आ रहा है. बताइए. नहीं आ रहा है. See, if I have 10 to the power 10 molecules of phenol, I will get 1 molecule of H plus ion. Yes or no?
Yes, sir.
Now you tell me, weak acid or strong acid? अभी भी नहीं. वीक ना. इतना ज्यादा हम एसिड डाल रहे हैं, उसमें एक मिल रहा है हमको, तो ऑब्वियसली इट इज वीक, है ना? प्लीज यूज योर इंट्यूशन. अच्छा, नाउ यू टेल मी समथिंग. इज दिस मैथमेटिकल और इज दिस इंट्यूटिव? ये देखने से पता लग रहा है ना?
Yes.
That it is, देखने से, all of you, yes or no? You can just say that it is a weak acid by looking and expanding what is given to you, right? You don't even have to remember this extent of reaction, right? So there are many ways to approach a problem. The best way, I think, is that you just expand whatever is given to understand whether it is a strong acid or strong base, or weak acid or weak base. Okay. Now, up to, I think your work is done, because for weak acid, how do we write? For weak acid, we write the concentration is C. Here it is 0. Initially, it is 0. The change is what? The change is minus of C alpha. And here the change is of plus of C alpha. And here it is of plus of C alpha. Yes or no, guys? Tell me.
Yes.
है ना? And in the, so I don't have to know anything about the about this particular phenol or also phenolate ion right now. I just want the concentration of H plus because it is saying what is the what is the concentration of phenolate ion. Okay, fine. So I need this C alpha. Okay, I need this C alpha. So I have alpha C, that is concentration. So C alpha is equal to concentration is 0.05 to alpha. And we know that for weak acid, alpha it is equal to under root of Ka upon C. Yes or no?
Yes.
We did this yesterday, na? Yesterday means the last class. This was the last topic, I think. K alpha is equal to K upon C. So you have the K, I know. K is 10 to the power minus 10. C is how much? 0.05. Bas. Now you can calculate, yes or no, tell me.
Yes.
Yes, Sarah. है ना? Okay, fine. Please try to focus on these parts, okay, rather than getting the correct answer, because this is something that will be repetitive in all of these questions, है ना? एक आपको एक सवाल का अगर जवाब मिल गया तो that is not going to repeat, but how you are doing the question, it is going to help you in the next question. So try to figure out and see some patterns while you are solving a lot of questions. Okay, fine. Any other doubt, Sarah?
No.
No. Okay, fine. So what were we discussing? Relationship between pH and OH, right? So pH and pOH, we have done this, right? Relationship between Ka and Kb. Relationship between Ka and Kb. Now, please remember what we are doing. Ka, that means of acid, and Kb, that is the conjugate base. What that means, relationship between Ka and Kb of a species. This relationship is only valid for a single species. Okay, for a single species. So, for example, if I have H, let me say if I have base plus H plus, right? Then it is going to give me an acid. Yes or no? Because acid, what does the acid do? Acid dissociates into H plus and conjugate base. And conjugate base, what does it do? It adds on H plus and gets acid. You can write an example. You can say that CH3 COO negative plus H positive is going to give me CH3 COOH. Right. So in this case, this CH3COO negative, this species, it is acting as a base because it is adding H plus to it. And this particular CH3COH, if you look at the backward reaction, it is acting as an acid. Why? Because it is liberating the H plus ion. Right. So for a single species, So if I say, that means in this, what we are going to calculate is the Ka of CH3COOH and Kb of CH3COO negative. So both of these things, they have a relationship between them, that the relationship is they are conjugate base. They are the conjugate acid base pair. Okay, so we are going to find the relationship between the K and Kb of conjugate acid base pairs. Let me write here acid base pair. Okay. So write this down. Let me know if you're done.
So can you scroll up a bit?
Yeah, sure.
Yeah, sir.
Done, guys, all of you?
Yes, sir.
Okay. Now, so let us take a simple acid, and then we will take its conjugate base. Okay. Let us consider an acid. So we have HA. It will react with water, and it is going to form H3O positive. Plus A negative. So for this is the reaction for Ka, and we can write the Ka here. So the Ka will be equal to the concentration of H3O plus into A negative divided by the concentration of HA, right? Because H2O is a liquid, and we don't write anything about the pure liquid and pure solids. Similarly, if I will write, this is the acid reaction. If I write the conjugate base reaction, it will be A negative. It reacts with H2O, and it will abstract the H from H2O, and it will become, what will it become? It will become AHA, right? It will become HA plus OH negative, and it will give OH negative. So it abstracted one of the H plus ions from the H2O, and it gave OH negative. So for this, I can write the Kb. This will be equal to the concentration of HA into the concentration of what? OH negative divided by the concentration of A negative, right? And we don't write anything about the H2O because it is a pure liquid. So the Ka and Kb. So if I multiply these two things, Ka and Kb, Ka into Kb, then what are we going to get? Tell me. So Ka is S3O plus into A negative divided by the concentration of HA, into HA into OH negative divided by the concentration of A negative, right? So I think from here you can see that we can cancel a few terms. A negative and A negative can cancel out. HA and HA can be cancelled out, and then you will get Ka into Kb, which will be equal to concentration of H3O positive into the concentration of OH negative, right? So what is this? Ka into Kb, it is equal to Kw. Okay, that means I can also write Ka into Kb. It is equal to 10 to the power minus 14. Please remember, for an acid base pair, okay, for an acid base pair, Furthermore, I can say that minus of pKa log लगाते हैं पहले, log of Ka into Kb is equal to minus 14. Now you can see what is happening here now. So you can also write log of Ka plus log of Kb is equal to minus 14. And you can also write log of or minus log of Ka plus minus log of Kb is equal to 14. And you can also write pKa plus pKb is equal to 14. Okay, so these are some relationship that will be useful for converting from Ka to Kb. So just tell me where I need to stop and from where you have to write it down. Just let me know if you're done, okay? Done, guys? Yes, no.
Yes, sir.
All of you done? Sarah, Samaira?
Yes, sir.
Okay. Write a question. Calculate the ionization constant of conjugate acid. Calculate the ionization constant of conjugate acid of ammonia if ionization constant of ammonia is if ionization constant of ammonia is 1.7 7 into 10 to the power minus 5. Okay, so we need to solve this. So write this question. Matthew, Sarah, you guys tell me if you're done.
Yes, sir. I wrote the question.
Wrote the question? Okay. I hope no one has the urge to just write the answer as 1.77 into 10 to the power minus 5. Okay. So please, if you read this question properly, so they are asking you to calculate the ionization constant of conjugate acid of ammonia. Okay. And they have given the ionization constant of ammonia. So these things are two different species, conjugate acid of ammonia and ammonia. So first of all, you have to write the reaction of ammonia with water. So NH3 plus H2O, and it is going to give me NH4 positive because it has a lone pair, है ना? It has a lone pair, it will donate the lone pair and it will abstract the H plus ion. So NH4 positive plus OH negatives, right? So it is giving me OH negatives here, right? OH negatives here. Okay. Now this is the ammonia. This is ammonia. And this is conjugate acid of ammonia because ammonia is acting here as base. And hence NH4 positive will be the conjugate acid of ammonia. Okay, so it is asking what is the ionization constant. So there will be a very strong urge in you guys that sir यही होगा, एक किसी को लिख देते हैं क्या हो गया, NH4 positive NH3 positive, same thing. No, it is not same. Okay, it is not same thing. These are different species. They have a relationship between them, but they are not same. So please, please remember my request that never write the same answer, even if you are even if you don't know, then please don't write the same answer. Okay, please don't write the same answer. Once you write this particular reaction and then you write Ka, it is given as how much Kb diya hua aapko, because we have been given ammonia is a base, and we have been given Kb, which is equal to 1.77 into 10 to the power minus 5, and they are asking the Ka, right? They are asking the Ka. So we know that there is a relationship between Ka and Kb, that Ka into Kb, and because these are pairs, right? These are pairs, this will be equal to 10 to the power minus 14. Okay. So now we have Ka, which will be equal to 10 to the power minus 14 divided by how much? 1.77 into 10 to the power minus 5. So you'll have 1 upon 1.77 into 10 to the power minus 9. Right, guys? है ना? 1.77 into 10 to the minus 9. Write this down. Let me know if you're done.
Done, sir.
Done. All of you done? Yes or no?
No, sir. No, sir.
No. Okay. Right.
Yes, sir. Done.
Done, all of you? Okay. No one is writing. Oh. Let us write about polyprotic acids and bases, because we will have many kinds of acids and bases. If I look at a particular acid, let us say HCl. So HCl can only give me one H plus ions and Cl negative, one H plus ion and Cl negative. But if I look at some acid, which is, let us say, H2SO4, now this can give me H plus HSO4 negative. Now this HSO4 negative can also give me H plus SO4 2 negative, right? So this is monobasic acid. That means it can handle one base, 1 mole of base, and this is dibasic because it has 2 H plus ions which can be liberated, 2 H plus ions which can be liberated. So now we will be talking about what happens if we have more than 1 H plus ion in a particular acid, or more than 1 OH negative ions. For example, if you have let us say CaOH whole twice, है ना? Or not CaOH whole twice. It's not a good example. Okay, let me tell you for the base. Let us first understand about the acid, right? Polyprotic. Acids and bases. Polyprotic acids and bases. Okay, so let me take an example of H2CO3. Okay, let me take an example of H2CO3. So H2CO3, it can give one reaction. The first ionization that it can have is H2CO3 is giving me H plus HCO3 negative. HCO3 negative. Now, for this particular reaction, I can write a Ka. Let us call this Ka1. Let us call this Ka1 because this is the first dissociation that can happen in H2CO3. So in Ka1, we will have the concentration of H plus divided by the concentration, into the concentration of HCO3 negative divided by the concentration of H2CO3. The second ionization will be HCO3 negative, can also get dissociated into H plus CO3 2 negative, H plus CO3 2 negative. And in this case, we will have the Ka2, which will be equal to the concentration of H plus into concentration of CO3 2 negative, whereby the concentration of HCO3 negative, right? HCO3 negative. If I add these two reactions, then I will be getting this HCO3 and HCO3 will be getting cancelled out, right? These two will be getting cancelled out, and I will be getting H2CO3 is giving me 2 H plus ions plus CO3 2 negative. Yes or no? Any doubt till here?
No, sir.
No. Now, but for this reaction, let me write the Ka for this reaction, and this will be the Ka because this is the overall ionization constant, and this will be equal to the concentration of H plus square into the concentration of CO3 2 negative divided by the concentration of H2CO3. Now, if I look at the relationship between the Ka and Ka1 and Ka2, you can see that if I write the Ka1, H plus concentration into HCO3 concentration, CO3 negative concentration divided by H2CO3. And if I multiply this with the concentration of H plus, that is Ka2 into CO3 2 negative and HCO3, then only I will be getting HCO3 negative will be getting cancelled out, and I will be getting H plus square into CO3 2 negative divided by H2CO3. Okay, so we can write that Ka1 into Ka2, it is equal to Ka. That means the first ionization constant into the second ionization constant, it is equal to the ionization constant of acid. But we can also write in general, this was only for H2CO3. So in general, I can write Ka1 into Ka2 into Ka3 into ... will be equal to the equilibrium constant of a particular acid. So these are simple relationship, and that is going to help you in simple problems, and 1 or 2 marks problems, or maybe 3 marks problem. And in that there will be a sub question which will give you where you will have to calculate the Ka, overall Ka. So write this down. Let me know if you're done.
Done, sir.
All of you. What about others? Matthew, done?
Yeah. 1 second.
Okay.
Yes, sir. Done.
Okay. Now I can write the same thing. For Kb also. So just write one more line. Kb1 into Kb2 into Kb3 into ... will be equal to the overall dissociation constant of a particular base. Right. Now, let us talk about the relationship between Ka1 and Ka2 and Ka3 and so on. So I hope you have written this. अगर नहीं भी लिखा तो कोई बात नहीं, लिख लीजिएगा, खुद से लिख लीजिएगा. But first you tell me about these two reactions, okay? These two reactions, 1 and 2. Tell me, is it easier to abstract H plus ion from a neutral species or a negatively charged species, where it is easier to get a H plus ion? Which one will be more easy, first one or the second one? Guys. What happened? Just imagine something like this. Now, you have something which is neutral. There is no charge. Okay, there is no charge. And then that means in no charge, it means you have the same number of positive and same number of negative things. But you removed one thing that is positive. That means you removed H plus ion. Now you have more negative and less positive. You have more negative and less positive. So those negative charges will be holding on to the positive charge, right? And they will not let the positive charge to get liberated or get dissociated very easily. So can I say that the first reaction will be much easier than the second reaction? Yes or no?
Yes, sir.
So we can say that the number of H plus ion that I'm getting from the first reaction will be way higher than the number of H plus ions that I'm getting from the second reaction, because from the first reaction itself, it is a reversible reaction. It has an equilibrium. So a fraction of H2CO3 is getting converted to H plus and it's HCO3 negative. And from that HCO3 negative, this is a fraction of this initial one. From that HCO3 negative, we are getting some H plus and some HCO3 negative only, because it is an equilibrium and it is a weak acid. So, and if the concentration of H plus is higher, the Ka will also be higher. Okay, the Ka will also be higher. So we can write a generalized note. Please write the acidic strength of polyprotic acid decreases as protons are lost. Because K is something that is going to give me the idea about the strength of a particular acid, right? The strength of a particular acid. So we have Ka1, which will be highest, followed by Ka2, followed by Ka3, followed by so on. Okay, followed by so on. Write this down. Let me know if you're done.
Done, sir.
All of you?
Yes, sir.
All of you done? Okay. Fine. Now, write factors affecting acidic strength. Factors affecting acidic strength. Number one, we will be mostly looking at hydroacid. Okay, hydroacid. Hydroacids means where we have H ions. That means hydrogen is directly attached to a particular central atom. It is directly attached to a central atom. So we will be comparing two things. Number one, the hydroacids of elements of a period. Okay, that means if I compare CH4, we will compare because see carbon CH4, it can also give me, I don't know how much it is going to give me H plus, but there is a possibility that it can give me H plus and it will give me CH3 negative. Similarly, we will have NH3, right? Similarly, we will have H2O and we will have HF, right? So there is a possibility, and all of them have H plus H atoms attached to the central carbon atom. Sorry, central atom, central carbon, central atom. Okay. So see CH4. If I look at a particular period and the hydroacids of a particular period, we have CH4. It is going to give me H plus plus CH3 negative. Then next we have NH3. It is going to give me what? It is going to give me H plus NH2 negative, right? Yes or no? And then H2O, H plus plus OH negative. Then we have HF. That is going to give me H plus plus F negative. Fine. Now, as you can see, we can talk about the acidic strength in terms of how many H plus ions it is giving, or we can talk about how easy can we break the bond, and how easy can we break the bond, or how easily the products can be formed. So if you are talking and comparing about how easily, what are we comparing here? How easily the products are formed. Okay, the products are formed. Now you tell me, do I need to compare the H plus as the products? No, because all of them have H plus, right? So I don't need to compare the stability of H plus, because in all of the products we have the H plus ions. Okay, so we cannot compare within the same things. We have to look at what is different here. So what we look that the conjugate base that we are getting, CH3 negative, NH2 negative, OH negative, F negative, these are different, right? These are different. Now, which of the following has the tendency to keep electrons with it? So the higher the electronegativity, higher will be the tendency to keep the electrons within themselves, right? So we will have F negative, which is most stable. We can write for the stability of conjugate base is equal to directly proportional to electronegativity. Within a period, we see the electronegativity, right? So in electronegativity, I can say that F negative is most stable, followed by OH negative, followed by NH2 negative, and then followed by CH3 negative. Okay. All of you agree with this? Yes or no? Tell me.
Yes, sir.
Yes.
Okay. And if the stability is directly proportional, and if F negative is most stable, that means F negative can be found very easily. And for the formation of F negative, I have to form the H positive. I cannot form F negative on its own. I have to form H positive. So if F negative is easy to form, there will be more and more H plus ions, and hence I can say acidic strength HF followed by H2O, then followed by NH3, followed by CH4. And because we are now comparing the acidic strength. So stability of conjugate base is directly proportional to the acidic strength. Okay. So write this down. Let me know if you're done. You must have written some points, I guess.
Done, sir.
All of you?
No, sir.
Acha. Read this question also.
Done, sir.
All of you done? Yes or no? Write the question also. Write the question.
Yes, sir.
So tell me, which of the following? First of all, look, how can we compare them? They should be at least in the same period or in the same group. So tell me, what is the case here? Same period. Don't compare hydrogen. Hydrogen same as sab mein. Okay, so you compare these things: phosphorus, sulfur, and chlorine. Are they of same period? Yes or no?
Yes, sir.
Yes.
Which period? All of them. Third period, right? Third period, na?
Yes, sir.
Yes, sir.
है ना? And which of the following has highest electronegativity? Phosphorus, sulfur, or chlorine?
Chlorine.
Chlorine.
Chlorine. है ना? So HCl will be highest, followed by H2S, followed by PH3. Okay, simple. Can I move on?
Yes, sir.
Okay. Now let us now look at the strength of acidic strength in groups. Okay, of hydroacids only. In a group. Fine. So in a group, if I compare HF, HCl, HBr, and HI, now in this case, there is two things. Okay, whenever you have a conjugate acid, so conjugate acid, the conjugate base, it will always have a negative charge. Yes or no? Tell me. They will all have a negative charge. नहीं, अरे रे, अब तो कैसे शांत हो जाता है? Yes sir, no sir, कुछ नहीं बोलते हैं. HA is going to give me H plus A negative, right? This is our conjugate base. है ना? So A negative always have a negative charge. Yes or no? Now tell me.
Yes, sir.
And we need to look at the stability. So acidic strength, now the acidic strength is directly proportional to the stability of conjugate base. Stability of conjugate base. Now, if we have a negative charge, then there are two things. First of all, now in the above case, now the size was similar for all of them. Okay, because they're on the same period, the size is very similar for all of them. So we compare the dominant effect, that is the electronegativity. But in this group, we have two things happening. If we go down the group, what is happening? The electronegativity is decreasing, but the size is increasing. Okay, the size is increasing. Now, when you look at this, you have to compare two things. I mean, you can compare how much a particular atom is able to hold the negative charge, or you can also compare the size. You tell me which will be more stable, A or B? Which will hurt you more, A or B, and which will not hurt you more? You remember that, na? Tell me which will hurt you more, A or B? नहीं, भूल गए, ये सब भूल जाते हैं. अरे, which is more stable, A or B? Both have a negative charge, but B has a large size. Which will be more stable?
A.
Yes, Matthew. Achha, which will be more stable and why it will be more stable? Stability, acha, you tell me. Stability is directly proportional to charge density or inversely proportional to charge density? It is inversely proportional to charge density, na?
Yes, sir.
Now you tell me, where is the charge density higher?
In B.
B में charge density higher.
There is more negative charge there.
कहाँ एक ही नेगेटिव है ना,
Oh, okay.
one negative only, right? There is only one negative. A negative, there will be only one negative. Okay, but the size is larger.
Yeah.
Size is larger. Okay, so in this case, I can say that B is more stable because it has less charge density. Because Q is same in both of them, right? Q is same, but if I divide this by volume, if I divide this by this volume, so VA and VB, so we can say that since VB is larger, the charge density, this whole terms will be lower. Okay, so when you are looking in a group, when you are looking in a group, acidic strength is given by the size of atom. Okay, now if the size is greater, then you will be having higher stability. So if I compare HF, this has the most wait a second, stability of conjugate base. So F negative will be least stable, followed by Cl negative, followed by Br negative, followed by I negative, है ना? Followed by I negative. And then I can also say strength of acid will be HF will be least acidic, followed by HCl, followed by HBr, followed by HI. Okay, another reason, please note down the another reason. Note. As we go down the group, the bond between H and atom gets weaker due to ineffective overlap of 1s orbital of hydrogen and larger orbitals of atoms, है ना? Because as we go from fluorine, second period, so it is combining with 1s and 2p. If I look at HCl, then 1s and 3p. So as the lobes become larger, there is ineffective overlap. Okay, the overlap is not effective, and hence the bonds become weaker. Since the bond is weaker, bond is weak, H plus gets dissociated easily. H plus gets dissociated easily. Similarly, you can write a question. Compare acidic strength. Compare the acidic strength of the group 16 element, what are those? H2O, followed by H2S, followed by H2SE, say H2TE, and H2PO. So in this case, you can write the answer. Because they are in the same group, and in the same group, size is the factor that is dominated, and it tells me about the acidic strength. So I can say that H2O will be least acidic, followed by H2S, followed by H2SE, right? Then followed by, so don't write polonium, just write till Te. Gets metal. H2Te. Write this down. Let me know if you're done.
Done, sir.
Done, all of you? Okay. Now, let us write a topic that is common ion effect. This is quite important. Okay, so please listen very carefully. Common ion effect. So you have to keep this in mind, and this is very useful when more than one acid or base or salt, acid or base or salt is added into a solution. Okay, so whenever you are going to add one acid or one base, sorry, more than one acid or more than one acid, one base, or you are adding one acid and one salt. And if you are having these different combinations, then this is very useful. Common ion effect. So see, let us take an example of acid. Please don't write anything, just listen. So it is going to give me, let me just write a simple reaction in which we don't have the H2O. Let me just write about H and A. It's going to give me H plus plus A negative. Yes or no, guys? Tell me. Any problem here? Any problem?
No, sir.
No problem. No problem, right? Okay. Now, if I add another acid here, okay. So what I am adding here, let me add HX. Then what is going to happen? Then I will be getting H plus X negative. Yes or no?
Yes.
Okay. The other case that I can have, I can add here, let us say, some metal and A, some metal and A. For example, you can see that what I'm adding here is, let us say HCl I am adding here. So I'm getting HCl, H plus and Cl negative. In HX, you can say I'm adding HI. So I'm getting H plus and I negative. And in MA, you can say that I'm adding NaCl. So this is metal and an ion. So it will dissociate into M plus A negative. Yes or no? Okay, so you remember these three cases. Okay, these three cases, and this is our original solution. And these are the things that I am adding, and you will be telling me what is going to happen. So let us talk about HX. If I am adding HX, then what is happening? The concentration of H plus is increasing. Yes or no? Tell me, guys. Concentration of H plus is increasing. Yes or no?
Yes.
Right? It is increasing. Now, if the human is increasing the concentration of H plus, what will the equilibrium do? Equilibrium will shift the, if I do this reaction, then the equilibrium will shift the original reaction backwards, because it wants to decrease the concentration of H plus. Yes or no?
Yes.
Yes.
Because now similarly, even if I add Ma, then what is going to happen? In this case also, A negative is increasing. If A negative is increasing, then also the original is going to go back. Correct? है कि नहीं बताइए? Yes or no?
Yes.
Right. So this is the common ion effect. This is known as the common ion effect. So if you are adding any chemical species, any electrolyte which has one ion that is common to the original solution, then it will lead to shift in the backward reaction for the original solution. It will lead to shift in the backward reaction of the original solution. Okay. Now we can discuss this. And I gave you a question, and this Sarah asked me the same question. So this is the question that we are going to take. So what did we calculate? We calculated C alpha and all. So we can take the C alpha from there. Okay, fine. So they are saying that the ionization constant of phenol is one. Achha, did you get the answer for this one? We did not calculate now actually. Achha. Let me just calculate the alpha. That will make things easy. Root of 10 to the power minus 10 divided by 0.05. So this is equal to 4.4 into 10 to the power minus 5. And this is alpha 4.4445. So let me just write here alpha 4.4 into 10 to the power minus 5. And let us start doing the question. So ionization constant of phenol is this much. What is the concentration of phenolate ion in 0.05 molar solution of phenol? And what will be its degree of ionization of this solution? What will be its degree of ionization if the solution is also 0.01 molar in sodium phenolate? Okay. So what it is saying, our solution, the solution that we have, it has two things. It has 0.05 molar phenol, and it also has 0.01 molar sodium phenolate. Okay. First thing is that to do this question, you have to know the structure of phenol. You have to know the structure of sodium phenolate. Otherwise, you can't even start the reaction, start the question. Yes or no, guys? Tell me. So whenever you get any these type of questions now, so please, if you don't know what is the structure, please Google it, and then just take a sticky note or something and then paste it with its name so that you can see this particular structure and the name relationship more and more times. Okay. So phenol, what will happen with phenol? So phenol we have it is going to dissociate into O negative plus H positive, right? O negative plus H positive. And the concentration will be C alpha. And the concentration of phenol ion will be C alpha. Now, we have sodium phenolate. So this is the phenolate ion, and there is Na positive here. So this is a salt. This is a salt, and we can also dissociate this into phenolate ion plus Na positive. Yes or no, guys? Tell me. Any problem till here?
No, sir.
No problem, all of you. So now you can see now that our original reaction, that is the phenolate ion of C alpha, it will get towards backward reaction. Can you see that happening? That since we have added the phenolate ion, that means we have added this particular ion. So the equilibrium, it will shift slightly backwards.
Yes, sir.
Right,
To decrease its
Sarah?
concentration.
Yeah, to decrease the concentration of the phenolate ion. Yes or no?
Yes.
Right. Okay. Fine. Now, if we move on and if we see this particular, so we have phenolate ion in both of the cases, right? In the presence of ion, how much of the, what will be the concentration of, what will be its degree of ionization? Okay, fine. They are asking me the degree of ionization if I have the solution is also 0.001 molar in sodium phenolate. Okay, fine. So the concentration of phenol ion is 0.05. Concentration of phenolate ion is how much? 0.01. Correct? This is something that they have given. Yeah, they have given these two things. They have given these two things. Okay. So I have phenol and then I have phenolate ion here. I have phenolate ion here. Concentration of phenol ion is 0.05. The concentration of phenolate ion is 0.01. 0.01. It is 0.01. So we can say that if I add these two reactions, the Ka, what will be the Ka? Ka, I can say that it is equal to the, wait a second, how much of it is going to get reacted? I have to think about that now first. Wait a second. Do we have anything about this? No. What will be, what is the concentration of phenolate ion in 0.05 molar solution of phenol? What will be its degree of ionization? Alpha. The solution is also 0.1 molar in sodium phenolate. Okay, so at last I have to calculate the concentration of sodium phenolate ion, and then I have to multiply that with the C, and Ka it is also given. The K is also given. Okay. Fine. So Ka, if I want to write the Ka, so Ka will be equal to the concentration of PHO negative, right? Total into concentration of H positive divided by the concentration of phenol, PH OH. Yes or no? Tell me guys, no problem. And this is equal to how much? 1 into 10 to the power minus 10. That is given to us, right?
Yes.
Okay. Now, you guys tell me, this salt, this will be a strong salt or a weak salt? It will dissociate completely or it will not dissociate completely? What do you think by looking at the charges? O negative and Na positive, right? So Na positive can easily get dissociated because we know that if I have NaOH, then it gets completely dissociated to Na positive and OH negative, right? That means Na positive is getting dissociated. If Na positive is getting dissociated, then obviously the phenolate ion is also getting dissociated completely, right? Yes or no?
Yes, sir.
Okay. Now, moving from that idea, I can say that the concentration of phenolate ion, the concentration of, we have got C alpha, na? So C was equal to here 0.05 into alpha was 4.4 into 10 to the power minus 5. This is the concentration of phenolate ion due to phenol. Fine, due to phenol. The concentration of phenolate ion due to the sodium phenolate, it will be equal to 0. Rather, I can say it will be 1 into 10 to the power minus 2 molar. Yes or no? Tell me. Bataiye.
Yes, sir. Yeah.
Right? Okay. So I can write the PHO negative, that means the phenolate ion total, is equal to the concentration of PHO negative from the phenol and the plus the concentration of PHO negative from the salt. Correct? Yes or no?
Yes, sir. Yeah.
So from phenol, it is very small. It is equal to 0.05. That means I can write this as 5 into 4.4 into 10 to the power minus 7. So this is plus 10 to the power minus 2. So we can see and we can tell that since this is very small, right? 10 to the power minus 7 and 10 to the power minus 2. So I am adding 0.01 and I'm adding this to 0.000000001. So it is not considerable. So what I will write, the phenol PHO negative total, it is equal to how much? 10 to the power minus 2. Fine. Any problem, guys?
No, sir.
No problem, na? Because this is very small, I am neglecting it and it will be equal to 10 to the power minus 2. So we have got all the Ka, everything in Ka, which is equal to, first of all, the concentration of PHO negative. We have got this as 10 to the power minus 2, that is equal to 0.01 into, we have also the concentration of H positive, right? What is the concentration of H positive? Okay, we will calculate that. Don't worry. The concentration of H positive, because there will be some dissociation happening and there will be some reverse reaction. Concentration of H positive divided by the concentration of phenol, that is 0.05. This is the concentration of phenol, and this is equal to 10 to the power minus 10. So we can calculate the concentration of H plus as 0.05 divided by 0.01 into 10 to the power minus 10, and I can write this as 5 into 10 to the power minus 10. Yes or no?
Yes, sir. Yeah.
Right? 5 into 10 to the power minus 10. Right. So this is the H plus. This is the concentration of H plus. This is the concentration of H plus. And what is alpha? Alpha, it is equal to the number of molecules that are getting dissociated. So this H plus is only, you are getting H plus from what? PHOH. Na? PHOH is giving you H plus PHO negative, that is phenolate ion. So we are having, how much is the concentration of H plus ion? That is 5 into 10 to the power minus 7. This much is dissociated. How much is undissociated that we have originally put inside this? It was 5 into 10 to the power minus 2. That is 0.05. Yes or no? This one is dissociated. अरे नहीं आया आप लोगों को. Concentration dissociated. Alpha is that much only, the fraction that is getting dissociated. Concentration dissociated by original concentration. Yes or no? Tell me. Yes or no, guys? Alpha. I think yesterday we defined this, right? Now, alpha is number of molecules that is dissociated divided by original concentration, that is undissociated. Okay, the undissociated one. So concentration that is dissociated is 5 into 10 to the power minus 7, because that much is the H plus, and H plus is only getting from phenol ion. Divided by the original concentration of phenol is how much? 0.05. That means I can write 5 into 10 to the power minus 2, and you can write this as 10 to the power minus 8. So this is the alpha, 10 to the power minus 8 in the presence of sodium phenolate. Okay, and how much did we get initially? How much did we get initially? Alpha was how much? 4.4. This was the alpha originally. Alpha is equal to 4.4 into 10 to the power minus 5 in presence of, sorry, in absence of sodium phenolate. In absence of, so you can see that there is a decrease in degree of dissociation if I add a common ion. Correct? There is a decrease in 10 to the power minus 8 is less than 10 to the power minus 5. Okay, so for Wednesday, we have two topics. First is the solubility of salt, KSP, solubility product, and then we have buffer. We have two topics, so there will be some time left, so we'll also discuss questions in that. And I'm not giving you any assignment today, and I want you to complete all of the assignment. Okay, you have to complete all of the assignment. So I think I have given you till 63 question, right? 6.2, I think. Yeah, 7.62. Yes, 7.62. Then we have KSP only. Okay, fine. Chalo. Thank you, guys. If you have written this, for Wednesday, we will have two topics. That is we have put acid and base in water. Now we'll see what will happen if I put salt in water. Okay, and then we will talk about buffer. Buffer is something that retains the pH. If there is a slight change in pH, we will understand buffer also. And then we will do salt hydrolysis. What will happen if I add salt to water? Can I stop sharing my screen? Yes or no?
Yes.
Yes.